So in today's video, we're going to be looking at histograms and some other types of graphs that you may not have seen before. So a histogram kind of goes back to what we were looking at last time when we were looking at frequency distributions, which had classes and the frequency of each class. Okay, so remember, a class gave us a range of values and the frequency was how many values fell within that range in our data set. Okay. Now, a histogram is just a way of representing that data. It looks very much like a bar graph, okay, where we've got these bars that go up and it's how many things were in a particular category. That's how high the graph is, okay? So normally, if you had a bar graph, the height of the bar is the number of things in that particular category that bar represents. In this case, what we're looking at is that each bar represents a class. So between each of these bars, we have the endpoints of each of our classes. So if you remember back to the last video, when we were looking at these frequency distributions, we did one with the heart rates of students. And I said to you that you have to remember that those classes actually include the decimals that would round to the values that are in that class. So the endpoints of these classes are actually like 56.5, 66.5, etc. because that first class here, when we looked at it in the last video, was actually 57 through to 66. But anything 56.5 and above would round to 57, so it would be in that class. And anything below 66.5, so 66.49 recurring and below, would fall in that particular class. So that is how wide we make the bar. We make it as wide as the highest and lowest decimal that would round to be in that particular class. And then the height of the bar is just the frequency. It's the number of things that fall into that class. So just remember, it's very much like a bar graph, but this time we are showing frequencies, in this case, for a range of values for each class. Okay. So this is what a histogram would look like. So for example here, it looks like we have two students would have a heart rate of between 56.5 and 66.5. We've got two students there. It looks like we have, I'm guessing around 11 students, 10 or 11 students by the looks of that graph, that would have a heart rate of between 66.5 and 76.5, etc. So this is how a histogram works. Why do we like them? Well, number one, because it's very useful to represent a frequency distribution. Rather than using a table, we can use a graph. But it's actually very good to look at the center of the data. Okay, by the center, I mean where 50% of the data values fall below that value, and roughly 50% of the data values fall above that value. We can see that this thing's pretty symmetric, okay? It follows this kind of a pattern. So we would know that our 50% mark would probably be somewhere in this class, okay? So our midpoint is somewhere between 76.5 and 86.5. So that's why we like histograms. We can get a rough estimate for the center of the data. It's also useful because we can see which class occurs most often, okay? Now there may be more than one class that occurs most often. So you might find that the highest frequency that you have of any class is, let's say, 10, but you may have 3 different classes that have that maximum value of 10, okay? So you may have multiple classes that have this same frequency, okay? So just bear that in mind. But as I said, it is very useful because we can see which class occurs the most and which class occurs the least. So in this case, we know that most of our data points lie in this class between 76.5 and 86.5, and the least amount of people fall in the class of 96.5 to 106.5. Okay. We will look at this in chapter 4, but just as a heads up, the class that occurs most often, okay, when we talk about most often, we tend to use the word mode, okay? Normally mode is used when we look at a single data point, but you can use mode to say that it's just the thing that occurs the most often. So the class that occurs most often in this case is our middle class here, okay, the third class. So whenever you see the most often, think mode. That will come up in chapter 4. You don't have to worry about that right now. We need to look at the shape of histograms, kind of like what I did up here. We want to look at different shapes of histograms and what that tells us. If we have a histogram, kind of like what we've got here, where it looks pretty symmetric, some data will give you more symmetric histograms than others. But if you've got a histogram that is symmetric down the center, we actually call it symmetric data. Okay, the histogram is symmetric. So if they ever say to you, is this histogram symmetric? It should look something on a graph. It should look kind of like a bell-shaped curve. Okay, it should follow that kind of a shape with the bars underneath it, obviously. Okay, but you should end up, this isn't very accurately drawn, but hopefully you get the idea. Okay. Okay. It will look something like that, where you could draw a bell-shaped curve over it and it would be pretty symmetric. Okay, that is a symmetric distribution. So each side is a mirror image roughly of one another, the left and right. You can also have skewed distributions. So there are two types of skewed distributions. Okay. You can have positively skewed data and negatively skewed data. And again, you can tell this by looking at the histogram for that data. If it is positively skewed, and this is kind of counterintuitive, so you need to remember what this looks like and why we remember it this way, okay? If it's positively skewed, it means it's skewed to the right. But being skewed to the right is actually the opposite of what you would think it would look like. So please bear this in mind when you do your homeworks and stuff, okay? If you have positively skewed data, you should have a histogram that would follow that kind of shape, okay? Which means that most of your data is to the left and you have this tail of data points that goes off to the right. So if you have positively skewed data, this is where it's kind of counterintuitive, it's actually skewed right, okay? You would think it would be skewed left because most of your data is to the left, but it is skewed right because we say it has this tail that goes off to the right, okay? But most of your data is on the left. If you have negatively skewed data, it's the opposite way around, where you have this tail on the left and most of your data would be on the right, okay? So again, you would have the bars underneath it that would represent the classes. And remember, each bar would be of equal width because each class has equal width in the data that we look at. But negatively skewed data would actually mean that most of your data is to the right and you have a tail on the left. So it is actually skewed left. So please remember that it's that way around. I know it's kind of counterintuitive, but you're always looking at where that tail is. So whenever you see a histogram, there's a few things that are good to ask from what we've seen here, okay? When you see a histogram, first thing you want to look at is the data skewed? Okay, so when you first look at the histogram of data, you want to see, is it skewed or is it symmetric? Okay. Second thing you want to look at is how many modes does it have? Okay, is there just one class that occurs most often, or do you have multiple classes that occur most often and it's got kind of like a weird shape going on where you have multiple peaks? Okay, if you have multiple modes, you would probably end up with a histogram that would look kind of like this, okay, because you've got multiple modes. Okay, you've got multiple classes that would have the highest frequency possible. And the third thing to ask is, are there any outliers? Okay. The way that you can tell if there are outliers is if you have a bunch of your data that's grouped really close together, but then you end up with a very, very long tail with just like 1 or 2 data points at the very end of that tail, okay? Those data points are really far away from the rest of your data, so they are outliers. So if you ended up with something that looked like, again, you would have like most of your data, let's say over here, I'm going to do something that's positively skewed here. So you would have most of your data over here, but then you had kind of a gap and then maybe 1 or 2 data points over here in these classes that are far off, okay? You would therefore have outliers that are far away from the rest of your data that lies in like the main classes. That's where most of your data is clustered, and you just have some random data points that are far off in some other classes. In that case, you know from your histogram that you have outliers. Okay, so they're the 3 main things to look at whenever you see a histogram. They're the 3 main things that you should ask yourself. So the next thing I want to look at is stem and leaf plots. Now, stem and leaf plots, they are technically a type of graph, but they are just a way of representing our data points to kind of appear more organized and systematic rather than just having like 50 data points all thrown together in no order. The way that we do this is we kind of break them up into like their units, their tens, their hundreds. Okay, so we break each of our numbers up and then we organize them systematically. So in this case, we have 5 data points, and our 5 data points were 97, 99, 108, 110, and 111. Okay. And what we have done here in our first stem and leaf plot, our leaves are just our units column. Okay. Our stems are our hundreds and tens column. Okay. So we can see here, okay, in our stem column, okay, for 97 and 99, okay, we have no hundreds column, okay, there's a 0 there. So we would have 0 in our hundreds column and then 9 in our tens column. So our stem is 0, 9, okay. Now the leaves that go with that are each of our units, 7 and 9, okay. Now our next stem, okay, we have a 1 in the hundreds column and a 0 in the tens column. So our stem is 1, 0. Now the only number that we have, and the only unit that we have that goes with 1, 0 is our unit 8. Okay, we have no other terms over here that start with 1, 0. They all start with 1, 1. Okay, now our next stem is 11. It's 1, 1. We've got a 1 in the hundreds column, 1 in the tens column, which are these 2 data points here. And then the leaves are any units that you have in your data points that are associated with that. So we have units of 0 and 1, which go here. Okay. So it's just a way of breaking up your data points. So when you read this, you know that you would have from here and here, I would have my data point 97. Then our next data point would be 99. Then we would have 108, 110, 111. Okay, so you can then just read them back off to make sure that you've got this correct. This one on the right here, all we have done here is just broken it up differently. So our stem is our hundreds column, and the leaves are tens and units. So it's the exact same data points, but we've just split them up slightly differently. So our stems, the hundreds that we have are either, in this case, I mean 97, you could put it as 097 if you wanted to represent it that way, I guess. We have either a 0 in the hundreds column because we're just dealing with numbers that have tens and units, or we have a 1 in the hundreds column, okay? We have no terms that are like 2, 3, 400, okay? They're all either 0 or 100. So our stems are 0 and 1, and then our leaves are just tens and units. So for our first 2 values, they're all just tens and units, okay? These 2 values here just have tens and units. They have no hundreds. So our leaves are actually the actual numbers. And then for the next few numbers, okay, they had a stem of 1 because they have 100. And then the leaves would be the tens and the units. So we would have 0, 8, 1, 0, 1, 1. Okay. So again, you can just read these data points off. So I would have like 110. Okay. It's just a way of organizing our data more systematically. Now, because of this, I'll write this here. We tend to order the leaves, okay? Especially when you have multiple leaves from your data points. So if you had, let's say, 10 leaves that went with one stem, okay? We tend to order the leaves because it just makes it easier to read off the data points. It looks more organized, okay? You don't have to. It's just kind of useful to read off the data that way. The other type of stem and leaf plot that you can have is actually a double-sided stem and leaf plot. Now, we like this because it's a great way of comparing two different sets of data. So in this case, they're looking at home runs of the two different baseball players, okay? And what they have done over like several seasons is recorded how many home runs each baseball player had each season, okay? So what they have done is our stem is actually down the middle. So the stem is in the middle, and then the leaves go to either side. So you would have leaves on both the left and the right in this case. The left would represent one set of data points, the right would represent another set of data points. So now I can say, okay, in some season, I know that Ruth had 0 in the stem, 3 in the leaf, which means that it's just 3. Okay, I've got no like tens going on here because my stem is 0 and my units is just 3. So I know in one particular season that Ruth had 3 home runs. Okay, now in a different season, I know that Bonds had 37 home runs. Okay, so I can read them off on different sides. We are not comparing, like, let's say for these two baseball players, we're not comparing for one particular season. Okay, I can't tell which season had how many home runs. I can just look at generally how many home runs did each of these baseball players have over their careers. Okay, so for different seasons, I have the number of home runs for each season, but I just don't know what season gave me how many home runs, okay? But I've got all of the data points here and I can compare, okay? So I know that Ruth actually had a lot of lower scoring seasons with a lower number of home runs than Bonds did, okay? But at the same time, I can see that he actually had a lot more high scoring seasons than what Bonds did, okay? Above 49, okay, Ruth had 4 seasons in which he got above 49 home runs, okay? He had 54, 59, 54, and 60 on 4 different seasons, okay? But Bonds, he had a very high scoring season for one particular season, but he only had one season that gave him above 49 home runs, okay? So even though Ruth had a lot of lower scoring seasons, he actually also had a lot of higher scoring seasons than what Bonds did. So this is where it's very useful because you can compare what's going on between two sets of data. Okay. The next thing that we want to look at is dot plots. Dot plots are super simple. There's not a lot that you need to know about them. In this case, we're looking at Chicago Cubs wins. I think we have about 40 data points here. And all you do is you just plot yourself an x-axis, okay, for your data points. And if you have a data point at a particular value, you just put a dot above that value on the x-axis. So in this case, I see that the Chicago Cubs had 3 different seasons in which they got 75 home runs, okay? So it just gives you kind of an idea of where your data points lie, because I can see that most of my data points are in this area here. Okay, I have a lot of data points in that area, and I have very few data points out on the two ends here. Okay, so dot plots just kind of show you where the data lies. And if you've got a data point at a particular value, you just put a dot above that value. It shows you how symmetric your data is, kind of like a histogram did, but we're just dealing with actual values here and not classes. But it shows you where the data points are. Okay, as I said, that one's super simple. There's not a lot that you need to know about it. They will ask you to actually plot some dot plots in the homework, and it's easy. You just click where the data points are. That's all of 3.4. For 3.5, there's a few things that you need to know. 3.5 is actually very simple. You're just going to be looking at some graphs and telling me, are they accurate representations of the data that is given? So they'll give you either a bar graph, or they could give you a line graph where you put a dot on each of the data points and then you join them up with a line. There's different graphs that they give you, but all you've got to tell me is it an accurate representation of the data that is given? Okay. Few things to remember. Number one, always remember that the y-axis should start at 0, okay? As I said, statisticians do not like graphs to start at anything other than 0. So if you get a graph that starts at something other than 0, they will tell you that it is not an accurate representation of the data, okay? They just don't like it in statistics. The second thing that you need to know is what a line graph is, okay? A line graph is very much like a bar chart, okay, where you're going to have data values on the x-axis and data values on the y-axis. And however, let's say you had like, I don't know, let's say years were on the x-axis there, and let's say that the y-axis was, I don't know, how many exams I had in a particular year, okay? So what I would do, let's say, I'll go up in 5s here, okay? I'm looking at how many exams I had in a particular year. So if I said, let's say in the year 2000, I had 6 exams, I would put a dot at 6 above the year 2000, okay? In 2001, let's say I had 10 exams, and 2002, let's say I had 12 exams, and then in 2003, let's say I had 7 exams, okay? A line graph would just put a dot above each one of those, wherever, like how frequent my exams were in each of those years, and then I would just join them up with a line, okay? That's what a line graph is, okay? So whenever you see those, be aware that that is what a line graph is. Another thing to remember is whenever you have a bar graph or a line graph, make sure that you have a good scale for the y-axis. Now in this case, I went slightly too high, okay? I could probably have gotten away with 15 being my maximum on my y-axis, okay? My largest y value is 12. You tend to go slightly above your largest y value. Just don't go too far. Okay, so number 3 is remember that you should have a good scale for the y-axis whenever you have a bar graph or a line graph. Again, it must start at 0 and make sure it's not too large or too small. So as I said, at the start, I may have gone a bit too large for my y-axis, okay? But also remember, it shouldn't be too small. Make sure that like your maximum value on your y-axis isn't equal to your maximum data point, okay? You want to go slightly above, just not too far above. That's a great way of representing your data, okay? And just make sure it's got a good scale. So don't go up in like, I don't know, in 100s, let's say, if you've got data points that are like 90, 95, 85, okay, they're all kind of clustered together. but you're going up in scale of 100. So you're going up with 100, 200, 300, but all of your data points are kind of scattered around, let's say 90, okay? That's not much help to you. So make sure that you go up in a decent scale on your y-axis. You don't go up in increments that are too large or too small. So now I quickly want to look at what application 2 will look like. You should be able to go ahead and do this now. You have seen most of the graphs here except for the last one, but that will be introduced in chapter 4. But you can still go ahead and do this right now and it will give you a feel for what's to come. What you're going to be doing is getting some of these graphs in Excel. So if you go to application 2, it will give you two documents. One of them is a Word document and one of them is an Excel document. When you open the Excel document, you should see at the bottom there are a ton of tabs. You will only need the first few. You don't need any that have an M at the start of them. You only need up to what is the box plot tab. But the first few you are going to be using for this particular application. And it's going to ask you, if you look at the Word document, it's going to ask you to form bar charts, horizontal bar charts, stacked bar charts. You're going to be doing a pie chart and a bar chart of two of the same set of data. You're going to be doing two different graphs for that same set of data. Then you're going to be doing a scatter plot, which will just put a dot at each of the data points. There'll be a histogram. This is actually the reason why you need the most recent version of Excel, because older versions of Excel will not do a histogram for you. And finally is this thing called a box plot, which we will discuss in chapter 4, but I'll get you to at least do the plot for now, and then you can go ahead and see what this looks like later on for other examples. So what I want you to do is for each one of these problems, okay, where it says bar chart, you're going to go to the particular data that is under the tab bar chart, okay? And you are going to be creating a bar chart with this data. Now, I'll do this very quickly for the first one, and then you can alter it however you need to do it. But what you're going to do is highlight your data. You then go up to Insert, and again, as long as you have the most recent version of Excel, you should come up with a ton of small charts and graphs here. What you're going to do is click on the appropriate one. Okay, you may have to flip through them to make sure that you've got the correct one, and then click on the graph that you want. And it will create a bar chart for you in this case, because that's the one that we've chosen. Then what I want you to do is I want you to try and make it as similar to the one that is here on the Word document, okay? So here you're actually going to be creating that same bar chart twice, but the first one has, let's say, an axis that starts at 0, and the second one has an axis that actually starts at 180. So I want you to be able to go to this chart, and what you're going to do is you're going to mess around with it and try and get the axes to start at different numbers. Okay, so I want you can actually right click and you can format different things. Okay, you can double click on that and a menu will come up, so you can format different things. I want you to also make sure, as I always said, that your axes are labeled and that your actual graph is labeled up the top, and I want you to make sure that they are labeled the correct things. Okay, in order to do that, you come up here to add chart element. I can add my axes titles, I can add my chart title, and you can actually alter it in different ways as to where you want it to be. You can also click on your actual bars and you can change the colors of them, okay? Which again, if you look here, we have two different colors of the bars, so you can do that to it as well. But I want you to try and get it to look as similar to these two here as you possibly can, okay? Again, it does not have to be perfect, okay? You don't have to make sure that the background is the exact shade of blue and that it's the exact shade of green. I just want you to kind of mess around with it. As long as it is mathematically accurate, okay, I'm happy. So you're going to do this for each one. So for the next one, you will go to the tab that says horizontal bar chart, and you're going to go to Insert, highlight the data, and I want you to get a horizontal bar chart out of this. And you're going to again make sure that your axes are labeled with the correct thing and that you have a chart title. So it looks as much like that as you can possibly get it. Okay. But again, as I said, as long as it's mathematically correct, I'm happy. Then you can look at doing a stacked bar chart. Again, that will be up here. There's loads of different options here. You've got like, you can do 2D and 3D if you particularly want. There's histograms, and then you won't need any of those, but there's like a ton of different ones. Pie charts if you want those. Okay, so I just want you to kind of mess around with it and make sure that you can try and get each of your charts to look as much like these as possible. So for this one, you have to do 2 different ones, because for the stacked bar chart, what they're actually going to do, if you look at this data, you have 3 different lists of data that you're putting all into one graph. So I want you to experiment with this to see if you can get it so that, like we have in this second chart here, where we have the 3 different bars for each country. But then I want you to see if you can also get a stacked bar chart where you have all 3 medals under one country and there's not 3 different bars, it's all one bar. Okay, so I want you to kind of play around with this, see what you can do, and make sure you read the instructions so that you get the correct graph. So here you need a bar graph and a pie chart. This one you need a scatter plot. So again, that can be found up here. You'll get a scatter plot from this one here. You can get a scatter plot. And then the other one you need is a histogram. So you're going to create a histogram of all this data. Again, it is an option up here. And the final one you need is actually, if you look here, it's a box plot. And what this does is it's going to compare the calories and the sodium in beef, meat, and poultry products. Okay, I know technically beef and poultry are both meat, but that's what they've categorized this as. But what you're going to do is you're going to be creating box plots, and I'll show you kind of where you're heading with this and what it should look like when you do it, but you'll have to go ahead and label it. We will do this later, as I said. It will come up again. It's under box and whisker here. Okay, and it should create a graph that looks like this. Okay, one of these graphs on each one is going to be the calories, and one of them is going to be the sodium level. Okay, for each of the beef, meat, and poultry. And we're going to look at what this actually means later on. It's actually looking at medians and the highest value and the lowest value, etc. But you don't really need to know that right now. I just want you to be able to get a graph that looks like this and make sure it is accurately labeled. So you're going to do this for each of these particular problems. There are 11 problems in total. Make sure you get every single one that it asks for, because some of these you've got like 2 problems in one because they're asking for 2 different graphs. So make sure that you get that on every single one. So there are 11 problems on here. You're going to be doing 11 graphs. When you do them, all I want you to do is, when you've got a graph like this and it is finished and all the axes are labeled and it's titled, I want you to copy and paste it into this Word document underneath the graphs that are here. So if you got the bar graph for this, you would just copy and paste each one here and here. Okay, again, as long as it's there, I'm happy. You don't have to like spend hours on formatting this Word document. Just make sure it's there, and then you will upload this Word document to Blackboard as your final submission. So make sure that you have the graphs that are already here, and then underneath you're going to put your graphs on this same Word document. Okay, that is all you need to know for now. So that is 3.4, 3.5, and application 2. Application 2 is due on Monday, August 31st at 11:59. So make sure that you have this done, but that's essentially what you're doing for this application. If you have any questions on this stuff, please let me know, and I will see you in the next video or in class.